Hello, Professor. My name is Nakul Raghav, and I'm from San Jose State University. And today I'm excited to present a project titled Real-Time Swimmer Pose Estimation in Underwater Environment using SAM-based segmentation and YOLOv7. This session addresses a very real complex challenge. How can we accurately analyze swimmers' movement when their bodies are constantly submerged, distorted by water reflection, and hidden by turbulent motion. Traditional video analysis method struggles here, but with AI, we can bring frame level precision and real time analytics into underwater sports. So the project motivation, like motivation behind this project, is clear. Coaches and athletes need objective and quantifiable feedback and an improvement under water conditions and make it difficult to manualize stroke efficiency, posture, or speed. By combining advanced segmentation and post-estimation models, we aim to automate this analysis pipeline, helping swimmers get better, faster, and more accurate feedback using real-time video data. So, advancing underwater sport analysis with AI. Traditional video analysis struggles with underwater distortions. AI-built tools, like especially where the AP like use like YOLO and SAM-based, like these tools enable field precision and automation. Segmenting analyzing swimmers can improve training feedback loops with the high frame with cameras and AI pipeline. The real-time analysis, as we can see the figure, like we can analyze the strokes using these YOLOv8, like what its stroke was, the if you enhance more, so we can also find the speed, swim speed, stroke rate, and distance per stroke. So these things are like a possible in today's world and motivated by the need for objective, like quantifiable performance metrics. So the methodology was simple. We use a two-phase like methodology. So just overview about it. In the phase one is swimmer segmentation from underwater video using SAM. So what we usually do, like using the SAM model, we like segment the images and analyze the posture of the swimmers using the SAM and YOLO model and using frame by frame image analysis, like it's measure the movements, like whether it is freestyle, backstroke, or the back flick movement. Phase two is the pose estimation. So continuing to that, so pose estimation, like using the movement using SAM, we analyze the pose of the swimmer, like the type if whether it's freestyle, whether it's backstroke, or like any stroke classification using YOLOv8 and MediaPipe. We have framed the resize and pre-process for like model compatibility here. Annotations and stroke classification are like also added dynamically per frame to like if a foot video has something like freestyle movement for 1 minute, so like annotation and stroke classification were added till that 1 minute, and outputs are combined into like an added video for like performance review, like whether like model is working correctly or not. So coming to the SAM model, like the Suma segmentation, leveraging meta segment anything model SAM. So SAM was analyzed with the fine-tuned sensitivity setting for like underwater conditions. Frames were like extracted, as we can see, like using the red part, we can like another swimmer in the image, and frame were extracted and pre-processed like in the BGR to RGB conversion. Multiple masks were generated and refined by the combined image segments, and the challenge, like there was some challenge too. Sometimes, like if it was like swimming in the sunlight, so we can like seeing like that it was analyzing reflections, but we overcome that. Sometimes turbidity or water turbidity or like overlapping mass. Final swimmer mass isolated for accurate post estimation input, like as we see in the figure. Coming to like the post estimation and store analysis where YOLOv8 and MediaPipe. So in the left we can see like using points like how we denoted like the movement of the swimmer. So like YOLOv8 actually detect the swimmer in each frame with like the bounding boxes. and the MediaPipe precisely tracks the 33 anatomical landmarks like the shoulders, like which is the obvious use in the swimming, or elbows or knees. Post landmarks, like we used to calculate joint angles critical for stroke identification. As you know, accuracy means perfection, so whether it's perfectly accurate or not. So we calculate the joint angles to identify, like, yeah, that's the perfect stroke we are using upon. Joint angle, like thresholds, used to classify whether it's freestyle, breaststroke, backstroke, or butterfly. Real time stroke classification shown frame by frame in the output videos, which we go one by one after the presentation. So this was like the end-to-end like Wi-Fi architecture. So coming to step one, it was like frame interaction, like select the keyframes from about a video. Step 2, initializing the SAM model, like we separate swimmer from noisy aquatic background. Object detection using YOLOv7, locate swimmer in the segmented frame. Like we don't want any reflection, we don't want any round data, so look to locate that. We use the YOLOv7, and for the post tracking, we use the MediaPipe that track the key joints for the accurate stroke analysis. In the project, we were giving breaststroke, freestyle, and all. Stroke classification. So, in the final, as for the project, we decided like this is stroke classification, identify swim stroke based on the elbow angles, visualization, output annotated videos with performance insights. We will come to that later. These were some technical challenges and mitigation strategies. First, segmented like noise, like that, which was solved by area-based mask prioritization. Second, it was like hardware constraints, like using Google Cloud GPUs for heavy processing, and personally saying in Jupyter Notebook it was not possible anywhere. Third was like the post detection, like the error underwater, tuning MediaPipe, thresholds, improved results, and fourth one was the manual annotation, bounding box, widget standard for consistency. Last but not the least, the large data handling file management for best practices applied. So coming to the results, so segmentation and post estimation insight. For the breaststroke, high confidence like 0.7 to 0.8 visibility with minor drop during full submersion. Backstroke, steady, high post detection using like during underwater phases. Butterfly, good detection but challenged by fast body movement underwater. Like overall, we can say like it get an 80% correct stroke classification when like above the water surface, and visualization improve clarity for like coast athlete performance education for the near future. So some conclusions and the future direction. So to conclude, like we should demonstrated like integrated AI-based swim analysis. Sam announced the background separation in the water footage. YOLOv8 and MediaPipe combined deliverable reliable post estimates, and for the future work, I can say that better and water landmark algorithms. It's not possible to use these all YOLO, MediaPipe, or we can say SAM for like without GPU. So yeah, underwater landmark algorithm integrate real-time feedback for swimmers during like practice session, like which will enhance proper understanding between the coaches and the players, like how the stroke was, how the joint movement, and how explore training data like for the expansion using synthetic and raw data set. Like we can provide a proper classified video for like to train the and like further data set, like not to like again rerun the process every time. We can just like train the model. Now coming to the videos, so now we will look for the videos. So so these are like the final like the analysis, like sorry for the like display, and they were the analysis for the core, like as you see. style is the backstroke, and it was like analyzed perfectly during this one. Now for the next pose, so now breaststroke was like directed with a proper joint movements. Now coming to the FL pose, like the butterfly pose. Sorry, my bad. So this was the butterfly for detection. Yeah, like we might see a bit early or like late accuracy, but after some few time analysis, we can see that with proper model, like the butterfly was like detected perfectly. So to thank you for listening, and I look forward to any questions you may have in maybe in the comments or for the professor it will be the mail. Thank you.